Hi everybody, today's video is going to be a little different just because my computer is broken and I can't write on it. So I went ahead and typed up the notes. I'm just going to talk through them. Again, like always, pause me when you need to. You need to get caught up. I'll let you know when we're about to go to a new slide so you know if you need to pause or not. So this new unit that we're going to be starting is more trig, yay, but it's a very different type of trig. It's much more algebraic. So we're going to be factoring and solving equations that have sines and coses, etc. in them. But the majority of our work is going to be just simplifying expressions. So what we're going to what we're going to use um, to do that are what we call trig identities. So first off, we need to know what an identity is because it's not special just for trigonometry. So an identity is basically an equation that is always true. When you first started solving equations, there were times where you got 3 equals 3 as an answer, and you probably wrote identity because that thing is always true, no matter what the value of x was. So that's what we're going to be seeing here is equations that are always true. A few examples of some identities would be x plus 0 equals x. Isn't that always true no matter what value of x you choose? Right? Another one, 1 times x equals x. Again, always true, but it doesn't have to be special like those are actually named identities, the multiplicative identity and the additive identity. It can be just something like this, 2 times x plus 3 equals 2x plus 6. Always true. And we know that's true because it's just the distributive property. So again, an equation is just something that's always true. So now we're going to look to see what some trig identities are. So if you need to get caught up, pause me. This is a great time. If not, then we're going to move on ahead. So trig identities come in several different families, and you actually know most of them right now. So good thing is we're just kind of formalizing what you already know. There is going to be a new little family, but hopefully it'll make sense when we get there. So the first type of identities that we're going to be talking about are called reciprocal identities. You know reciprocals. We've graphed reciprocals. We have found values of reciprocals. So identities are, again, just kind of formalizing them. So our first set of reciprocal identities deals with sine and cosecant. So we already know that sine and cosecant are reciprocals of each other. That means that sine is 1 over cosecant, right? We can just take cosecant and flip it over, and we've got our sine. So if sine is equal to 1 over cosecant, then cosecant is equal to 1 over sine. They're reciprocals of each other. So what this means is, as we go working through these problems, anytime I see a cosecant in a problem, I know that's equivalent to 1 over sine. And maybe I'll make that substitution to help me simplify the expression. Okay, so sine and cosecant we know are reciprocals. Another pair of reciprocals we know are cosine and secant. So same idea, cosine equals 1 over secant, and secant equals 1 over cosine. And then, of course, our last pair would be the tangent, which equals 1 over cotangent, and cotangent, which equals 1 over tangent. Okay, so these are all identities we already know. We know the relationship between sine and cosecant, etc. Okay, so these are reciprocal identities. Again, pause me now if you need to. Otherwise, I'm going to move on to our next family of identities. Okay, the next identities are called quotient identities. Again, this is something that maybe we haven't formalized, but I'm thinking it'll be an easy jump to where we've been. So a quotient we know is just a fraction or a division problem. So I'm going to start with tangent. We already know that tangent is equal to y over x. We've done unit circle stuff. Anytime we had an ordered pair, we took the y over the x and we had our tangent. But what else do we know about x and y, or y and x? Well, I know that y is the same as sine and x is the same as cosine. So I can make that substitution. So another way that we could refer to a tangent is to say it's sine over cosine, because that's just y over x. So this is a quotient identity. We're turning tangent into a quotient of sine and cos. And then because we know about reciprocals, we can say that the reciprocal of tangent, or cotangent, is equal to the reciprocal of sine over cos, which is cosine over sine. So tangent is sine over cosine, that's just y over x, and cotangent is cosine over sine, which would be x over y. Okay, so again, those are our two quotient identities. Okay, next slide. Next slide are kind of the big guys. And again, this is kind of where we get to the new stuff, but hopefully it'll make sense as I talk through it. So this last family of identities that we're going to be using a ton are called the Pythagorean identities. And the word Pythagorean should make you think about Pythagorean theorem. And really, that's all that these identities are they're referring back to the Pythagorean theorem. So I've given you a circle here. I'm going to start by by throwing a triangle within this circle, and we've used triangles in our unit circle a lot, right? So I'm going to put a triangle in. I went ahead and labeled my angle theta. Now, what do we know about the sides of this triangle? Well, we know the horizontal, our x, is the same as cosine. We know the vertical, or the y, is the same as the sine, and I'm going to call this my unit circle, so I know that the radius is 1. So I label the sides of my triangle with cosine of theta, sine of theta, and 1. Okay, nothing new. But now let's think about this in terms of the Pythagorean theorem. So the Pythagorean theorem would say 1 leg squared plus the next leg squared equals the hypotenuse squared. So let's do that. We'll just put it in terms of cosine and sine and 1. Okay, so I can now say that cosine theta squared plus sine theta squared equals 1 squared. That's what the Pythagorean theorem tells me for this triangle. And that's really the first Pythagorean identity. It's just cosine squared plus sine squared equals 1. We are going to clean up the formatting a little bit. When you're dealing with trig functions, it gets really awkward if we have to do parentheses and squared all the time. So what they've done to kind of combat that is we're going to take out the parentheses. We're going to bring the exponent in. So really how we will write these will be cosine squared theta plus sine squared theta equals 1. Okay, so it's identical to the line above it. It's just without the parentheses. So the exponent comes in, but that means cosine times cosine, or cosine squared. So that is your first Pythagorean identity. That's the big guy. Cosine squared plus sine squared equals 1. Now, there's 2 more that we're going to get out of this same triangle, dealing with our other 4 trig functions. Now, you can memorize these. I'm not going to suggest you memorize these, although you need to know them to use them. Of course, you need to know them. So here's what I do every time I need to use my identities. And, I've taught this stuff for over half my life, and I still do not have these next 2 identities memorized. Okay? Every time I use them, I write this out, at least in little shorthand to remind myself. So don't think that I want you to stick this in your head and just memorize it. Okay, I want you to know where they're coming from so that we can derive them quickly as we need them. Okay, so I know this identity. This is just Pythagorean theorem. What I'm going to do to find my next one is I'm going to divide through by cosine squared. And I've chosen cosine squared because it's one of the terms in the equation. So I'm dividing the cosine squared by cosine squared, and sine squared by cosine squared, and 1 by cosine squared. Okay, and then simplifying each of those terms gives me a second identity. So the first term, when you look at it, is cosine squared over cosine squared. We know that's 1. The second term is sine squared over cosine squared. Now, I feel like we just saw something in terms of sine over cosine, right? Sine over cosine, or y over x, is just tangent. So when I say sine squared over cosine squared, that's tangent squared. So the second term in this equation is just tangent squared. The last term in the equation, 1 over cosine squared, again reminds me of something we just talked about. 1 over cosine is a secant. It's a reciprocal. So 1 over cosine squared must be secant squared. And that is the next identity. And I'm going to move my little, there we go. Now we can see it. Okay, so the first term just becomes 1. The second one is tan squared because it's sine over cos, but they're both squared. And then the last term is secant squared because it's 1 over cos, but again, they're both squared. So there's our next identity. 1 plus tan squared equals secant squared. Okay, pause me now because I'm going to move to a new slide because I don't have room for the next one on here. So pause me now if you need to get caught up. Okay, so, oops. There we go. I ruined my surprise. Okay, so for our third identity, for our last Pythagorean identity, again, I'm going to go back to the Pythagorean identity I know. Cosine squared plus sine squared equals 1. I've already divided through by cosine squared. Now I'm going to go through this equation and divide by sine squared, because again, that's another term in this equation. So dividing everything by sine squared will give us a new equation or a new identity that we can use. So first term says cosine squared over sine squared. We know that's let's see, cosine over sine is cotangent. If you look back at your reciprocals, so cosine squared over sine squared is cotangent squared. Middle term is sine squared over sine squared. That's just 1. And then the last one is 1 over sine squared. And again, we know that 1 over sine is cosecant. It's the reciprocal of sine. So 1 over sine squared is cosecant squared. And there's our third Pythagorean identity. Again, I don't have all of these memorized. Okay, I've got the first one. I know cosine squared plus sine squared is 1 because I know the Pythagorean theorem. I don't know these next two or these last two. So please don't feel like you have to memorize them. I'd rather you understand how to get them than memorize them for a month and then forget about them. Okay? So my last slide here, I just have all three on the same slide. So all three Pythagorean identities. And then when we get to class, we will start figuring out how we can use these to help us